So this time the graph only tells us the center, but not a point. So what do you do? And
choose a line that it intercepts.
yeah, good job. So he did point out that it's 0, 0. So Bailey, since you said it, which one did you use?
I used the one in the top left box.
That one right there?
The one below it.
Okay.
Yeah, that one right there that you just.
Okay. So -2, 1. If you pick a different point, will your answer be different?
No.
No, it shouldn't be. It should be the same. So our center is 0, 0. Let me label that HK. And we'll talk about how this looks at the end, but so far this is what we know. Remember that with a graph, you can draw in, you don't necessarily have to draw it even, but I think it helps you see, and then just count boxes instead of doing all the subtraction. So 2 and 1, right? I think though, just again, I think it's good to keep reviewing that. So 0 minus -2 squared plus 0 minus 1 squared, just to keep reviewing this. Because I think, I don't know about tomorrow, but maybe next week I'll have one where it's just text. That's what I intended to do yesterday and it didn't work out. So we're just doing the distance formula without the square root part, because we don't want r, we just want r squared. So you can skip the square rooting. So 0 minus -2 is 2, and 0 minus 1 is -1. What happens when we square -1? Yeah. So it's just 4 plus 1, or 5. And that just gets plugged in right there. Alright, so this is what I was going to mention. Do we need to write the zeros each time? Does it change anything if we do? No. So you could on this write just x squared plus y squared equals 5. It isn't wrong to write x minus 0 and y minus 0, but you don't have to, because it doesn't change anything. How'd that one go? Okay. All right. Just to look at what we were doing yesterday with a little bit more, and I have one more that we'll do after this as an example, but the concept we talked about yesterday, central angle equals arc measure. Remember that? That was kind of the big idea. And we talked about an arc being a section of the circumference, just a piece of it, like the pizza crust on a piece of pizza. And then, let me leave that for a second. Like if this was 70 degrees, the arc measure is also 70 degrees. And we said minor arcs, typically we use 2 letters with the arc symbol above it, and then major arcs over a semicircle would be 3 letters, still with arc. It is really, really important if you're going to say this statement, that arc UV equals 70, it's really important to make sure you say measure of, and we're going to see why today. Anyway, that is not 70, I was just making up a number to review some concepts. So we are trying to find arc YTU. So YTU, this is the one we're looking for. I'm using a little m. Know that they are the same, the central angle and that arc. So how? What's a good way to do that in this case?
I would assume that arc YX and arc UV were equal because of the vertical angles.
Awesome. Here's what she just said. Looking specifically at that group or pair of angles is the same as theta, right? Because the vertical angles is what she said. So those are congruent. So we can just add these up. and we'll get 101. And then that is the same as the arc measure. It didn't ask for that, but just so we know. So measure of arc YU is also 101 degrees. What would the measure of arc UTV be? No, that's angle, sorry. UV, measure of arc UV. Good, don't say it, but he's got it. Good, Braden. Bailey, good. Good, Linda. Good. Okay. All right, so go ahead and everybody say. Should have said this. 79, not 8. How come? Go ahead, Linda.
180 minus 61 and 40.
Yeah, good. So, I guess it depends which way you look at it, but there's a diameter, so this whole arc is 180 degrees. And we know that 61 and 40 are part of that, so we can subtract those and get 90 or 70. What about here? Do you remember what kind of angles those two are? So let me put a dot. Those two angles? They are supplementary. Since there aren't parallel lines, we're not going to say the same side or alternate ones. So these are a linear pair because they form a straight line, and so they are supplementary. So you could have also done that, like 101 plus this one is 180, so that makes this 79, and then go out from there. So either way, just wanted to remind you of the linear pair because those come up in these kind of problems. And then let's look at this one because it has some algebra in it with the expressions. I think we can just look at it and do it together, and then I'm going to give you time to work on that sheet that has a little bit of this. This one is not on that sheet. So we are trying to find measure of angle XST. So this one. How should I notate that one? Just put a question mark. What do you think?
Do you like W looks like a diameter? You could set like 32x minus 3 and 14x minus 1, set it equal to 180.
What do you guys think? Okay. Just graphically, here's what he said. This looks like a diameter, and your paper says anything that looks like a diameter, assume that it is. So that makes this arc 180. Yeah, is that what he said?
I think he said set them equal to each other.
Did you say set them equal to each other?
I said set it equal to 180, I think.
Okay. I thought I heard 180, but
Sorry, guys.
it's okay. It's good to check. Anyway, so like he said, like both of them said, now we can just set these, add them, and set them equal to 180. We haven't done this in a little while. Let's just go ahead and do that. So what's your next step? Good, so we have 32x plus 14x, which is 46x. And then negative 3 and negative 1 is negative 4. Now what?
Add both sides.
Good.
And then divide.
And what do we get? 92 should be 4. Okay. All right, and then the problem actually asked for the angle measure. So how do we get that? So we have an expression for the arc, which is congruent to the angle. Okay? So I'm going to say measure of angle XST is equal to measure of arc XT, which is equal to 32 times 4 minus 3, which I believe is 125.
Yeah.
Okay. So you'll see some of that on that work from yesterday. In fact, why don't you get that out? Any questions on this one? Yeah. And let's just spend some time working on that. So number one, just angle is the same as the measure, so it's 120. Number two, same thing, 123. Number three, we had to do a little bit of calculating to get there. So we're trying to find arc. Now look up here because it's the pink from C to F to D, so it's the long way around, right? And we know that because it's 3 letters, and remember F is telling you to go the long way, not just from C straight to D. Anyway, we know that E to B is a diameter, so we can find this angle is 180 minus 135, which is 45. And now we can stick that here because of vertical angles. Okay?
You got 54.
What?
Measure of safety.
No.
I got 306.
So did
Which is what I should have done.
It's okay. I was like, wait, how did you get such a small number?
Yeah, it's so take this from 360.
Okay.
That's weird.
It's okay.
Okay, well, good job. So if you didn't catch that, it should be 306 for that one. Number 4. 146 is your answer. Basically take these 3, 86, 154, and 60 away from 360 to get this region, the SU. And then in it 60. And then you get 60 plus 86 for the angle. Okay, number 5, you should have got 234. And these two tell you that they're the same. It's a vertical angle that's congruent to 126. Together it is. So if we, let's see, how do I want to say this? It's 180 from E to B, and then we just need I wish it had a center point, but we need arc CB, or angle B center, C, whichever you want to think of it as, so that we can add that to 180. So where did I get 54 right here? Yeah, so these two we said add up to 126. And this is a diameter, so we can just subtract. Okay, and then again, that vertical angles thing, that's coming up a lot, so it's a good tool to use. Here again, actually, 55 can be copied down to the bottom at ML for vertical angles. Now, it's kind of interesting. This is an arc, right? A measure of an arc. So we're not actually doing vertical angles, just jumping from JK to ML. We're transferring here our 55, then here, then there, is really what we're doing. Because there's not vertical arcs. It's not something we say. But it kind of you can think of it that way, kind of. Next one, which by the way, that one's 125. I forgot to say that. Okay, number 7. X should be 8. That's just solving with a diameter. So these diameters are really important to see. Did you add? You subtracted 8, that's why.
No, I added
No, you subtracted because you had 32 right here. It should be add 8 to get 48.
No, that's completely different.
You had this, right?
Yeah, but I didn't subtract 140 from 180.
Well, here, did you have -8? Because I think you had +8.
I am -8.
Oh, well then what did you write here? Did you write 148?
No, I am. Yeah.
So it should have been, here it should have been 132. When you combine these two, it should be 132 and then subtract. Alright, number 8 is a -x. Is that okay? As long as it doesn't make an angle or an arc measure negative, right? -x is okay. Okay, number 9. So, let's see, where's my scroller? There we go. So, x is 11. You can see it down there. Here's kind of the, do you want me to talk through the strategy, the plan? Okay. So you're given that these two angles are the same, so we can copy 5x plus 10 there, and then that whole chunk is vertical to 12x minus 2. So we set 2 of these 5x plus 10s, so I'm looking down here. Set 2 of those equal to 12x minus 2, because those are vertical. And that's how you get 11 for x, and then this time it actually specified to solve for an arc. Notice the previous 2 didn't say, it just wanted you to solve for x. So you have to take that 11 and plug it, sorry this is kind of not neat, but plug it back in to solve for the arc. Okay? And again, it's, so 5 times 11 plus 10 is plugging that 11 in for 5x plus 10. And then using the diameter of SV or TW. Does that kind of make sense? Okay, how'd the front side go? Brayden, how'd it go for you? If you didn't finish the back, I'm going to let you work on that tonight. We'll check the rest of it tomorrow. If you did finish, just hang on to it. We'll check it tomorrow. Sound good? Okay. So just for this last little bit, I want to give you the formula and introduce the idea of arc length. I can't read that. Did it say 1 or 7? Looks like a 1. Okay. All right. Length is highlighted because it's got the same word in front of it, not in this sentence, but normally when we say arc length. Okay? And I told you yesterday arc measure and arc length are easy to get confused. I think if you, as long as you're understanding what length means, it makes more sense. Arc measure, I've always said, is kind of a weird, it's a weird thing to measure about an arc to me, but this doesn't. To me, this makes more sense. So, let me pull this thing so you can see the comparison. The measure of an arc is a fraction of 360. So knowing that all the way around is 360 degrees, the arc measure is the fraction of that total degrees. Whereas the arc length is a fraction of the circumference, which is what? Describing circumference means what? Yeah, it's a distance or a length, right? In other words, if we actually took this circle that's on the screen right now, we could measure the distance around it in inches and probably get like maybe 25 inches or something, right? It's actually a length that we could pull a string on and measure. So you're good on the difference. Okay, let's focus on the next part, which is this. Fraction of the circumference. We saw the wire problem being bent around that circle. How did we figure out what fraction it is? Remember? So we'll just use this orange piece if we wanted to know the length of this. We know it's a fraction of the whole circle, circumference. What information would tell us what fraction it is?
or the radius?
It will play, no, good thought though. It plays a role in telling us the circumference, right?
Was there like the equation for circumference that we use?
So we'll use that. Okay, so think about where we've been. Circumference is 2, let's use the other one, is pi times diameter. Everybody good on that? Fraction of means we need to multiply that by something. So what if I told you that this is, let's use an easy one, it's not this, but let's say it's 60. Actually, let's go even easier for the first question. What if this was a right angle? That was how the wire was. And you said it, do you remember? What fraction of the whole circle is that?
1/4.
A fourth. How did we know? Yes, the angle tells us it's fourth. Silvana, what were you going to say? Okay. All right.
490s mean 360.
Yeah, the whole way around that center point is 490s, right? Okay, so now let's switch this back to 60. 60 degrees. So what fraction of the whole circumference is that orange piece if that's 60 degrees? So it's this. Go ahead. Yeah, it's 60 out of 360, which is 1/6. Make sense? So we would say, oh, hey, that little orange piece is 1/6 of the total circumference. Okay, then we could just make up some other ones. What if it was 120? Yeah. 120, 1236 is a third. Okay. So those are the easy ones. If I said, what if it's 128? Well, now we don't know. Not just by our minds, but we could just punch that in, right? So what goes in here is the angle theta out of 360. That's our fraction. It's whatever piece of the total angle that arc is being made by. Okay? Here's what the formula looks like. N, they're using as the degrees. I think we'll change it to theta, if you're okay with that. And S is completely strange, but that's the letter we use for our arc length. I mean, it makes no sense, right? So that's going to be something you'll have to just kind of get used to. But S for arc length. Let's go write that in there. So guys, it's just an angle fraction of the total circumference. That's all. We could summarize it by saying that. So I'm just putting some length measurement units in there just to kind of, I'm hoping to visually cue you to distinguish between measure and length. Okay, in fact, let's put a, I don't know how you want to do this, but I'm going to put a line here. This time I do want to tell you what these are. So S is arc length. Strangely, theta is the central angle. And then this is the circumference. In the picture, let's put a center and huh? Oh yeah. I think you're leaving. So guys, it's just another formula. As long as you're plugging in correctly, I think it's fine. Just divide whatever central angle you have by 360 and multiply that by the circumference. Remembering that circumference could be made of two radiuses, right? Instead of a diameter, depending how it's given. Either way you want to do that. But from there, I think these problems aren't really too big a deal. So I'll just kind of work this one with you. In a circle with a radius of 4. Here's what I would do. I would start by drawing that and labeling 4. Okay? What is the length of an arc that has a measure of 80? And it should say degrees right there. Okay? So tell me what to draw next. Okay, she said another radius, because I need to chop out an arc, right? It's like cutting, if you just cut one, like if this is your pizza and you just make one cut, you can't pull a piece of pizza out and have an arc, right? So just stick another one on there. The 4 can go, it's fine, you don't have to have it. And then this is what we're trying to solve for, is the length of that. Where in the picture can I write the 80? That would be helpful. Here, right? Even though it says a measure of 80, remember this is the same as the central angle because it's the measure. So you can put it here. Okay, and then we say S equals theta out of 360 times pi times diameter. So theta is 80 out of 360 times pi, and what is the diameter? 8. Yep. Okay, then we can just punch that in. So why don't you grab your calculator and do that for me? Sorry, go ahead.
5.58.
Okay. Right, and then of course we would want the units, but we're not told what they are, but we would want to put those on there. Oh, it says to the nearest tenth. So what would this be rounded to the nearest tenth?
4.6.
Good. Cool. That's all. Pretty easy. Okay. Do you feel like you want an example in your notes? Happy to do it? Yeah? Okay. Let's do that. You know what? I think we could squeeze 2 examples in here. The next thing is area of a sector, which is very similar to this. So maybe we can split it down the middle. So let's draw a circle first. And how do I want to let's leave the circle and write a problem statement, because I want you to be able to do it without a picture. That's what I'm trying to say. We're going to say 8 centimeters. And then let's say has an arc that measures, and we're going to put 115 degrees. Okay? So we'll do two questions. One, what is the length of the arc? And then, I don't know that we'll do this today, we'll probably come back to it. But go ahead and write it. What is the area of the sector of the arc? Okay, so we'll see, we might get to that. Okay, so what is the length of the arc? An arc that measures 115 degrees. So let's draw the arc first. So we need a radius of 8. And that's probably not quite 115 degrees, maybe like that. Okay, so the green on the picture is what we're given so far. Where else can we put the 115? Yeah. So copy it down to the central angle. That is not showing up as a 5. Good enough. Okay, write the formula. S equals theta out of 360 pi times diameter. Okay? And then just fill out what you know and solve. It's kind of the usual steps that we take. What's the diameter? 16. Okay. When you get that, Bailey, what do you say?
Yeah.
You got 16 right on the nose? It's really close, because this is roughly a third, and that is...
Yeah, 16.05.
Okay, let's do it. We'll call it 16.1 centimeters is the length.
Yeah, 16.05.
Okay, guys, real quick. The fact that we said fill out what's given should tell you that maybe I give you an arc length and ask you to solve for theta. Or I give you an arc length and theta and ask you for the diameter or something, okay? In other words, a formula solves both sides. It's not always that we're just putting numbers in the right side and solving for x. Just like we've seen lots, right? All right, we'll pause there.